This is the formula we already did, and just like that we have negative predictive value. Remember, in positive predictive value increase with prevalence, PP. This is the very thing important to see. It is the directly proportional to prevalence, whereas negative predictive value is with prevalence, whereas negative predictive value decrease with the prevalence. They actually have disease. Then we have negative predictive value. It's the proportion of patients who test negative actually do not have the disease. And we know the formula, and it is inversely proportional to prevalence. Then a very important, sometimes they ask the definition, like remember, incidence is the new cases of the people at the risk during time period, whereas prevalence is the existing cases. So how they make this question a little bit tricky. They will give you, okay, like this treatment, new treatment, that this number has increased. So it will make like existing cases will increase, but new cases will not be added. So you must remember this. I will like discuss this question after. I will create a question series for biostat. But remember, prevalence is the existing cases and incidence is the new cases. Totally like saying in the like earlier, like how affected by mortality, curability, reoccurrence of disease. If mortality is increasing, curability is decreasing, means person are getting cured and there is less reoccurrence of the disease, that decrease the existing cases, that is prevalence. So, and prevalence equal to incidence is the short spanning of disease. If they can give you, okay, they can say in the question, disease is short lived and incidence equal to prevalence, or this very important slide. Now we have the variation in the incidence and prevalence. So since incidence depend upon the occurrence of new cases of disease, decrease in incidence. So new cases may decrease if we can say there is an increased resistance to the disease, change in the disease etiology, the same etiologic agent is not causing the disease anymore, and then we have effective prevention program that reduce the exposure to the known risk factor. Just like we will see the scanning respect like early, there will not be disease, just like that it will not cause any new cases. So this is of the disease, a decrease in incidence, a shorter duration of disease due to either improvement, there is a more improvement method, means there is a more curability and less reoccurrence, more recovery, or increased virulence lead to more rapid death. Like the death is very fast, that the existing cases are very less. Now we have odds ratio. So odds ratio, first of all, it is for the case control. How we're going to like measure this one also. So just like we did true positive and false negative, we can draw the table. Remember, in case control, they what to or it will make. Then we have relative risk. We have the risk of developing disease in exposed group. So we are going to so this thing we have to remember, less than 1, more than 1. So if the relative is equal to 1, then the risk exposure is not the risk factor. And if it less than 1, then it is a protective factor. It is a negative association, it is protective. Whereas if R is more than 1, the exposure is the risk factor. The question is given to cover the relative risk. So it's just draw the table by AD, right, like CD. So we like now we have attributable risk. The difference in the risk between the exposed and unexposed group. So proportion of disease occurring that it attributed to the exposure. Okay, so it will be like A risk. Then we have relative risk reduction. So in relative reduction, we will do 1 minus relative risk. It's the proportion of the risk reduction attributable to the intervention when compared to the control. So remember this. It's very simple. We have to make 1 minus RR. Remember, relative risk we are dividing, whereas attributable risk we are subtracting A plus B minus C plus C plus D. And in that thing also you have to read the question carefully what they're asking. Are they asking the exposed group first or unexposed? So read the question carefully because the value will change. If they are asking, then it will be C by C plus D minus A by A. This is the attributable risk reduction, remember. So this is the reduction and they have changed the C will plus C plus D will be, this will be this one, they will subtract like this. Sometimes they will give you, if 8% of the patient who had received a placebo vaccine developed the flu versus 2% of the patient who received the flu vaccine, then attributable measure the absolute risk reduction, then they will say it will be 8 minus 2 6. And if you want to convert it into like the percentage and 6%, then it will be equal to 0.06. So it will be absolute risk reduction is the difference in the risk, not the proportion. This thing, remember, it is not the proportion to the intervention compared to the control. So the come earlier. So this is the question, absolute risk reduction. So remember, let's read the question. A study examined the association between diabetes and periodontal disease. The result indicated that the risk of the periodontal disease was 10% for those with diabetes and 5% of those without diabetes. What is the absolute risk increase associated with the diabetes? It will be 10 minus 5, that is 5%. So this one is the example in which they have absolute risk reduction. who needed to be treated for one patient to benefit. If we want to benefit like the one patient, how many number of patients we need to treat it? So remember, then we number needed to harm, number of patients who needed to expose to risk. Like we have to expose that people, one patient to be harmed, and in this one harm we have only 1 by AR, 1 hour. Higher NH means the treatment or lower chances of causing heart failure side effect. They usually don't ask, sometimes they can ask the number needed to treat it, so but it is important, but not important. Very, very, very important, that is confidence interval. The first thing I would say is this one,